SoundStripe.
Back with the E46 project. It's been a while. We were at PRI for a little bit. Everyone got sick, so little delayed on the video, but we're back nonetheless. Right now, we're super close to getting this thing started. And we're just going through all of our pre-checks. So that means making sure there's no leaks, making sure that all of our components in the cooling system is holding pressure. Along with that, we got to make sure a lot of the electronic things are on point. Right now, to showcase a couple of things we've done underneath the car as we have it up, we got all of our lines for our power steering all completed. We got all of our hoses in place, which is a little bit of a task on its own because we need to, as you can see, there's not a lot of room, so we need to make sure they don't kink, they don't touch anything that's rotating. And we also have all our oil lines done. Right now we had actually found a leak that we're taking care of right now, and that's just part of that's why we do these checks. It's part of that way when we start it up, it's not like, we don't have oil freaking squirting everywhere on all our new things, which honestly is the worst thing. Personally, I hate that. That's why I'd rather take the time, check all these components, so when we do the first start, we can worry about more important things rather than small little leaks. One way we do some of our checks is through this machine here is a smoke machine. Kind of find a way, make a little contraption or whatever, shove it in a hole and kind of let the smoke go into the system, and we kind of see where it kind of seeps out. That way we have an idea that there's a leak or we're good and sealed. One example of this was I stuck this in the dipstick hole, which is connected to the sump. After pressurizing it, let it do its thing, there was no leaks. That gave me the okay. If there was, I even, just to make sure everything was actually, the smoke was actually in the sump and everything, I actually undid one of the drain plugs, and you could see it just pluming out. So that's one good way to check and let you know kind of what's going on with maybe a component that you didn't tighten, or a gasket or a seal that's been compromised, just to let you know right away. So here we have the Driveline Calculator on the Spicer website. We just took some of our measurements off of our driving member, off of our driven member, which was the same 2.2 degrees, which puts both of our attachment points parallel to each other, which is super important. That coupled with the angle we took of our actual drive shaft, which was 2.45 degrees, gives us an operating angle of 0.25 degrees on both sides. So this is a very ideal situation. All right, now that we've kind of showed you how we calculated some of these angles, I kind of want to explain into more detail. I know we touched on it last video, but I wanted to tie our bushing into this and the reason for this. Basically, you have to correct this side, our driven member, to be parallel with our driving member. As you can see in the calculator, we need these things to be completely parallel in order for all of our operating angles to be A-OK. The reason why we even have to make this is stock E46 M3, it has a two-piece drive shaft. So basically, this is the angle on the driven member is quite aggressive to meet with a center bearing, and then that kind of fixes itself to the transmission. In this one-piece case, we don't really want that, so that way we fix this side to be parallel with that side. Now, if you see, because we took care of that, all of our U-joints are at, as you can see with our calculator, they're at 0.25 degree angle, which is very little angle on them. The maximum for U-joints is 3 degrees. They do have a minimum, which is 0.5, but being a little bit less than that is not a terrible deal. They have a minimum just because there is grease in there, there's needle bearings, you want a little bit of movement so those things can be lubricated properly. You have a very, very ideal 0.25 degrees operating angle on this U-joint, along with this one as well. This is important for smoothness. It's important for the longevity of the component. When it comes to swaps, I feel like a lot of people don't focus on this element of the swap. Because if you were to use, say, a two-piece joint and try to make it work with this, or make a one-piece joint work with that angle on this side, you're going to get most likely more than 3 degrees operating some of these joints, which is, I mean, it might be okay for a little while, but it's going to be a problem down the line. I mean, that's not what we're looking at.
We're at the point where we're super close to cranking this thing up and firing it up for the first time, but we have run into an issue with our actuators. These things, I must have mentioned this in an earlier video as well, but they are responsible of controlling all these individual throttle bodies. There's one on each bank. Right now, these are unresponsive, so we have done all the pedal calibrations and all the TPS calibrations that we need to do in the ECU in order for them to operate properly, but we have no response. So I just wanted to touch up on how these kind of work and like what's kind of involved in the whole unit itself. One thing I would like to touch up on is it's just how they function. If you have wired or calibrated any type of like a Bosch style drive-by-wire throttle body, you'll know that it has its power, ground, its internal TPS, and on the way how the motor actually moves, it's usually a half bridge type output from the ECU that provides a low amperage current, either in the positive or reverse polarity, which kind of makes it do its thing. In this situation, that's not the case. These things run on CAN bus, which makes it super more complicated. But it's probably the reason why these swaps are like very uncommon, because just to kind of have these work, you're gonna need a stock ECU and its own calibrations to make it all work. So the CAN bus portion of how these things function kind of adds a extra layer of complexity to kind of having it swap into other stuff. If you have a stock computer, stock calibration with the ECU, you don't have any issues there. It's all built in on how they set the ECU up with all these different parts of the engine. But say if you're doing a swap, you don't have an SCS Delta ECU like we're using, you're gonna have a lot of issues with just getting the ECU to do a lot of the basic functions. Just because these things they're kind of locked to the car in a way, and to get them unlocked and working freely, like it's a lot harder than it might seem. But that's why these kind of swaps are so uncommon up until kind of recently, where some of these ECUs are a little bit more attainable for the regular people. So this ECU has all these protocols basically pre-calibrated for us to use. We're just at a point where like, it's not working. At this point, we have a couple different ways to go about it diagnosis-wise. As you can see here, this is the board of the actuator. There's like a lot more going on than you'd think from looking at it from the outside, but it has its own like microprocessor, a whole bunch of different power transistors, and that's, I think, what is going on at the moment is one of these power transistors have gone bad. This is a common thing when the gears start to go, as it has to kind of adjust the way it applies power to the gears, and it kind of overloads the voltage regulators and the power transistors in the board. So we got a couple of actuators coming. Hopefully, put those in, and and that'll fix our issue. But as of yet, we cannot fire it up. We have done all of our pre-checks, make sure all of our coolant is holding, all the oil is holding, and all the other fluids are in. So we're super, super close. We're gonna have to figure this issue out first, and then we'll come back. I just want to take the opportunity to kind of address some of the comments that we've been getting. We're super appreciative of engaging with the video, and whatever questions you might have, we're more than welcome to answer them. You know, we're not gatekeeping any information here. We'd love to help out another person do something like this for themselves as well. But yeah, we got a comment from Remy, probably up here. We'll pop that up. But he was wondering about the subframe and the oil pan and the exhaust manifolds, how we adjusted them or modified them to fit. And yes, all three of those things were modified. The oil pan was cut and clearanced for the subframe. The subframe was also cut and reinforced. And the exhaust manifolds were also cut and kind of redirected according to the room we had in the chassis. I'm sure Wolf will put in some videos and clips of showing that, because we do have a bunch of those. But yeah, if you guys have any other questions, hit the comment section, let us know. Yeah, we'd love to just get to them, really.